Hey guys, my name is Prakash Pathak and welcome to this video. So what we are going to do in this video, we're going to learn about GraphQL. And if you don't know what GraphQL is, here is a quick summary. I have 50 different tabs already open. So let me get settled over there. And okay, so this is actually what GraphQL's official website says. It's actually a query language for your APIs. So basically, if you have APIs, you have a long language to query data from your server, from your client, right? So it makes things very easy. You don't have to write a new route or route in order to basically get a new piece of data. You define the structure and you get the data from the backend. Okay, that sounds interesting, Jay, but how to make it? We'll definitely be covering that. So don't worry about that, right? So this is GraphQL. The official GraphQL libraries are good. By the way, if you don't know, this GraphQL is actually developed by Facebook. And yeah, Facebook. A lot of people don't like a lot of things about Facebook, but still, this is developed by Facebook. And we'll learn, but we'll not learn this official one. So what we'll do is we'll learn something called Apollo GraphQL, which is a wrapper around GraphQL, which is better. Basically, this provides additional features which could actually help you to make GraphQL applications much more easily, right? So just get lost. Okay, so let's go to the place where it's called developers, because we are developers, and let's go to documentation section. Now, I would guide you. I would just request you, don't go through all this mess. Just simply go to the enterprise guide. Oh, you can't see that? So I'll just move myself away. Yeah, can you see this now? This enterprise guide section, right? Just go that introduction. This is great. Okay. Yeah. Wait. So, is it principled guide? No, this is not for sure. Okay, so let's get started. Simple, right? There's a lot of Apollo GraphQL packages, like Apollo GraphQL for Express, for Koa, for a lot of platforms. But what we want to use is Apollo GraphQL for Express, right? We'll write that up and we'll have this thing called Apollo GraphQL. No, we don't want that. Yes, this is the place where you want to be when you start developing in GraphQL. So there are a lot of packages and you must be like confused which package should I go with, right? So there's a very good section which actually describes which package you should actually go with. So it's something like this. So if you're using a serverless environment, just go with that. If you're not, choose an HTTP framework, right? Which is our need, right? The next is directly use Apollo servers. Like if you don't want additional HTTP like routes, you don't want to make additional HTTP routes, but we want to, so we'll be going with the other way around. So the option is basically to go for Apollo Server Express. So that's the library we'll be using, and you'll be asking, okay, Jay, but how should I start on this? It's pretty simple. Just click on this and you'll have all the basic template which you should start with. So yeah, once we have that, let's actually fire up our terminal and start developing the project, right? Right, let me make my terminal a little bit bigger so that it's visible, neat, and clear. Okay, so let's move to desktop, right? And let's create a dictionary called learn GraphQL, right? And let's go inside this folder called learn GraphQL. Once we are here, the next thing we have to do is basically initiate a new node project. And if you're here, I assume you already know how to initiate a node project. It's very simple, right? So you have to just say npm init and like answer a lot of questions, right? And if you don't want to answer them, simply hit -y, and there you go. We have a package.json completely built and ready. Now the next thing which we require is the package which we just saw. No, not this one. This is from a program which I was making before. So not this one. The package is actually Apollo Server Express. So I'll just copy that from there, and just give me a sec. Okay, I'll just copy that from there and paste it over here. So you have npm install Apollo Server Express, and you'll have Apollo Server Express in your application set up pretty neat. So let's wait for this thing to basically get done. Yeah, it's done. And let's now open the Visual Studio Code, the editor of choice, the weapon of choice of all the developers, right? Okay, so I will just hide this sidebar. Okay, so I hope so this thing is visible to you, right? So let's actually start writing the program. By the way, I'm writing the same program which you saw as a startup template, but I'll also be explaining that right now. So yeah, if you want to know how I'm expanding this, is Control B or Command B if you're on Mac. So let's create a file called index.mjs. I'm using mjs because this gives ES6 syntax. I can use this without compiling it. I can directly run it on Node. So that's a very big advantage. So the first thing which I'll do is I'll import Apollo server from the. Also, this is visible, yeah. So I'll import Apollo server from Apollo Server Express. So wait, Apollo Server Express, yeah. So there's something called Apollo server, not error server. Next thing what we need is we need two things. I'll just copy all the imports, right? So all the imports are here, right? So we need all these imports, and then the first thing we will be creating a function which will start Apollo server. So this will be an async function, and we'll say start Apollo server, right? And then it takes two things: type defs. If you don't know what type defs are, it's completely fine. No one I'll definitely be going with that in a while. So you have two things. One is called type defs, and other one is called resolvers, right? So let's call it S because we'll have a lot of them. And the next thing what we want is we want to construct an Express application, right? Bind that application with the Apollo server. So how to do that? It's pretty simple. Let's create an HTTP server first. So we'll call it http.createServer function, and this function basically takes your app. So now this server is binded with this app, and the next thing what we have to do is actually create the server, which is our Apollo server, right? So this takes several configurations. First thing which it takes is type defs. Second thing it takes is resolvers, which we are getting from those parameters. Third thing which it takes is CSRF prevention, which is a security thing, and it is very much recommended to have it on, because this could have very severe security flaws if you don't make it turn on, right? Next thing, we need two plugins, and I'll be going with what those plugins do and why do we need them. So yeah, so you have Apollo plugin HTTP server, right? And then you have to pass on the HTTP server which we have created, and Apollo server, yeah, this one, the second one, right? And and what we'll do is we'll pass a parameter called embed to be true over here, right? So you have both of these set up. Wait, both of these not set up because this is the one which we actually have to use over here. Yeah, so we have both of these set up, and I'll just go through them, what they do. First is this one, right? So we have Apollo server plugin drain HTTP server. What this plugin does is basically it helps your HTTP server to shut down in softly, not like damn, it's cut off. That's what it does. The second one is basically the Apollo UI, which you will see in a while, to be there, present in your application. So once you have your server, I think the most intelligent thing to do next is basically to turn it on. So we'll say await server.start. So you have your server started, up and running. The next thing what we'll do is we'll apply a middleware, and this will actually help us to use our app, which is the Express app, and bind that to our Apollo server, right? So all the requests which is like not served by this will go to this. Basically, that's what it is for. And then await new promise, right? So we'll have a new promise, and then resolve reject two things. We get, I think, HTTP server which we have created dot listen, and then you will have to give port at which you actually want to listen. So let's give it, what port should we choose? 4000? Yeah, 4000 is cool. And the next thing is, let's pass the second parameter as resolve, and this is actually a function. So this will be automatically called once this server starts and starts listening. So basically this promise will resolve at that time, and we have written await, so this will be, it's basically, yeah, you got the point, right? So we have promisified a callback based thing. Yeah, this is neat. I think this is very intelligent solution of basically promisifying any callback based thing. Okay, the next obvious thing is you'll ask, okay, Jay, this is cool, but where is our type definition? Where is our resolvers? So first of all, let's understand what is type definition and what are resolvers. Type definition is pretty simple. Type definition is like the model, the structure of your data, which you actually want to fetch, modify, update, do all those CRUD operations on. So, okay, but how do I define it? Come on, should I write some fancy magic tricks? What should I do with this? How to create this? So there's a very neat solution to that, and there's something called GQL, which is graph query language. I'm not pretty sure about that. So there's something called GQL, right? And that GQL can actually help you to design the data for your GraphQL server. So we'll go through that right now. So let's make for now, for just give me 2 minutes, right? For just understanding purposes, we'll have a smart data set. So let's say, right? So this is a temporary data set of some students, right? So so basically this is an array, and every student has a name. So let's start with roll number, right? So it's like roll 1, right? Wait, okay. And every student has some name. So let's keep it me as the first student, and maybe a subject, right? Which is maths, right? So let's say, what is their major? So this is their major, the maths, right? So we can just go on and create some other students as well. Let's say we create 4 students. Let's change the name: Rohit, John, Garima. Okay, that's cool. Okay, so we have certain names, and let's change the subjects as well as to roll number 2, maybe 3, maybe 4, and we'll have English, and maybe computer science, and maybe chemistry. By the way, how many of you like chemistry? I do not hate it, but it's very hard for me. When I was in class like 11, 12, organic chemistry, learning all those name reactions, yuck, it was too much for me. Yeah. If you are from India and you have prepared for IIT-JEEs, you can highly relate. Yeah. So this is temp, and this is an array which we would like to fetch from our GraphQL server, right? So if you look at it, like, just hold on, just be at your place, just look at this data. This has a structure, right? So every student have a roll number, name, and subject, right? So let's quickly define that in GQL, and let's call it type defs, right? So, and how do you do that is you just import GQL. So I did that, and just that didn't import it GQL. I think that's available over here. So you can call it GQL, And with Apollo Server Express, you get GQL, right? So once you get GQL, what you have to do is, you can directly do this. Okay, and there you go, right? So once you do that, you can specify the structure of your data quite easily. So let's define it. So the first thing which we'll call it is type, right? The first type which we want to define is student type, right? And the student type, right, will have a roll number, which is an int, right? Not like that, an int, right? A name, which is wait, you don't need a comma over here, right? So you don't need that. So string, and then an subject, which is again a string, right? And by the way, if you wait, okay, and if you have a doubt that something might not be available, right? So it's like when you return it, like let's say the father's name, right? So there's no father's name. Let's say some of them have, some of them didn't. So what you can do is you can provide an exclamation mark over here. That means that thing might not be there, right? Okay, this is your type student. But hey Jay, what's next? The next thing is, what do you want to do with it? So you want to query this, right? You want to query this. So the next, there are some special types. So you have the student type. There's some special predefined types in GQL. One of them is called query type. So let's use that. So let's create a query type. You cannot have a query as some other type. So this is query types. And then you have to tell this particular thing that, what do you want to query? So I want to query basically the students. So I'll call it students, right? And what will this return, right? So if I query student, what will I get? I will get a list of students. That's how you call list basically. Anything which you wrap around a square bracket is actually a list. So you will be returning a list of students. Oh, that's cool. We have our type definitions made. Yeah, we just asked GraphQL that there's a type called student and we can fetch it with a query called students. That's pretty much cool. Okay, let's move ahead. But the GraphQL knows, okay, student and a query, but we didn't do it, right? We practically have to do it. And that's the place where we practically apply the schema is called the resolver. So how do you make a resolver? Let's make a resolver, right? So there what you do is pretty much simple, just a simple object, all peace in your mind, nothing else. So we have a resolver, and then these special things which you have, right? Query. So you'll have to handle all your queries over here. So you'll say, a query, right? And then inside the query, see, inside the query you have students, right? That's the same thing what we are doing over here. Students, and that's a function for us, right? And that function, you do whatever, you do yada yada, whatever. You do a database call in real scenarios, you do a database call, you do everything what you wish, and then you return the data which the client wants, right? And in our case, the data which the client wants is the temp data, right? So we'll be returning this temp, right? So we return temp, we have this resolver ready, we have this type depth ready, and quickly let's start the server with the type depths and resolvers which we have built. So we'll just copy this around and start the server. So we'll say this, okay, we have our type depths. No, we don't want that. Type depths, and we have our resolvers. So type depths, resolvers given, and this should basically fire up our server without any issues so far. So that's quite cool. Let's start it up. So there we have our terminal, right? So let's call it node index.mjs. Okay, GQL has already been declared, so I think it imported, but there you go. So that's not the one. Do you want it from here or here? I don't know. Let's remove it from here. Let's see. Whichever works. So yeah. So we have removed from the top unknown type string. I think it was this one was correct. Okay. Okay. Did you mean Oh, the spelling is wrong. Both of them are correct. Basically, you can import them from here as well as here, but there's a spelling mistake, which is typo. So string, string. I don't know. Why did I misspell string? I don't know. Okay. This started pretty successfully, but I think we missed something over here for sure. What did we miss? Let's look around. So, okay. So, we missed nothing, but basically the server started successfully. But just to give an indication that the server started successfully, let's write server started successfully. Yes, and happy sign. Okay. So the server started successfully and we are done. Okay. So let's move ahead. Let's go to our terminal and let's try to fire it up once more. Yes, the server started successfully, and if you remember the port, it's 4000. The next thing what you have to do is you will have to fire up your terminal, I mean your browser, right? You have to go to your browser, go to localhost port 4000 where we were. Okay, that's cool. I think okay, we did not specify the GraphQL location. Just give me a sec. Okay. Okay, so one of the things which we forgot, right, is when you apply this middleware, you can also specify something called a path, right? And this will be the path where you want to serve that GUI of the GraphQL basically. So right now we'll be giving it at the home directory. Most people do it like at GraphQL, something like that, but I'll do it at the home directory right now. So let's stop our server again and fire it up again, basically. Yeah, and let's try to go over here again. So once you do that, you will have a beautiful UI just for you. This was some of my previous tests, so I'll just remove them, and there you go. So now we can actually query students. So even you can do this, or you can just say, okay, I want to query this one, and this one, right? So I want to query all the parameters out of students. And so once you execute this, see, we get our data. We get our data as we expected it to be, and that's pretty much cool, right? And you can modify it. I don't want the roll number. I only want like the name and the subject. There you go. I only want the name. There you go. So you have your GraphQL server working. But that's not pretty much it, right? You need to step up, right? You need to add more students, right? You want to add more students. And whenever you need to modify data in your GraphQL server, that's what we call mutation, right? So that's a mutation. So if you modify the data, it's called mutation. And how to create a mutation in GraphQL? Let's have a look. Let's have a quick look. So here, if you see, we have type definitions, we have type query. Similarly, we have a special type called mutation as well, right? So how do you create mutation? So let's call it add student. So we want to add a student, right? Don't worry, we'll be learning how to design big scale multi-schema GraphQL servers as well, but let's get down these basics first. Okay, so you basically can give a parentheses over here, and you can specify what all things you need to create a student. So I need a roll number that should be an integer, right? So a roll number, a name which should be string, maybe roll number, name, and subject, right? I need all these three things in order to create a student. And basically, what will it return? You can specify that as well. So let's say it will return the newly created student which was created, right? So it was like something like this, right? So like this, or you can define a custom type over here as well. So let's say add student result, something like that, right? And you can say, we'll be returning a message which will be of type string, and and the student itself, right? So student, that will be the student, right? So you can specify a new type over here, and then you can just, you know, use that over here. Here you can see the data which we are receiving very successfully, and we were talking about how actually can we add new students to that array from this particular place, right? Using the GraphQL query language. So basically, it's not that difficult. Right? So what do? You have your I was talking about, you have your query type, right? Then you have your mutation type. You define what mutation you have. You define what data you need for doing that mutation, and you define a return type. Once you do this, you'll have to write a resolve. Like, you'll have to resolve them, right? So you have the query, you have mutation, you have your mutation over here, and then you have to write add students, right? And here you get the root, which is the parent container. Then you get the arguments and you get the context. You get these things. So let's call it CTX for now. And in this argument, you have all the elements, and then you actually have one more thing, which is info, which we will not be using, right? We only need this arguments. So this argument is like, you know, what the person who wants to add a new student have passed over here, right? So argument dot role is that roll number, argument dot name is that name, and subject, and so on. So what we want is, we want to basically take our temp array and push a new student with root. Okay, let's not do it. Let's call it new student. It will be it will have a roll number, which will be args dot roll. It will have an email. Sorry, no email. It will have a name, which will be args dot name, and it will also have subject, right? So it will be args dot subject, right? There you go. You have the new student ready, and you can push it now to your temp array. And now the return type, remember, you have to return this element matching to the type which you have written over here. So that should be a message and a student. Simply write a message, which will be new student added successfully. This is the message, and then you actually have to pass the student which you have created, right? Which is new student. So this is the mutation which we have written. Simply a function with these 4 parameters, which is root, arguments, context, and info. So once we have that, you know, we'll be seeing how we can write this up, right? So yeah, let's pull it down for a second. You have this query, right? The next thing what we want to do is, you can just click on this, you know, you can see the students query, right? So I'll just restart the server. I've restarted the server, and once I've done that, you know, I can just refresh this particular page, and now I will have a query as well. So I mean, I will have a mutation as well, like this, and we can say, wait. We do not want a query, we want a mutation. How to make a mutation? Okay, you can go to schema, and you can see your mutation over here, right? And if I say this open in Explorer, yeah, you can have it, right? And once you click this plus, you'll see the mutation query over here. And the next thing what you have to do is, you'll have to specify what results you want. So I want message, and I also want the new students. That student's roll number, name, roll, and the subject, right? So I want all of these things. And then what I can do is, I can say like you know, something like okay, so we have roll number, name, and subject, right? So you can say over here, you can say roll, and now this will create over here, and you can see here we have variables, right? So that's the place where we'll be passing from. roll number, name, and I think subject. So we have all these three things, right? So what you have to do next is basically supply their values over here. So for roll number, sorry, for the roll number, we'll be supplying maybe 6 over here. For the email ID, for the name, we'll be supplying maybe something like Ron. And for the subject, we'll be supplying Hindi. Oh, yeah, that's a subject, that's a language. I think you know that. So yeah, and once you send this request, if you notice to the response that we have got, it is actually the message which we wrote in the resolver, and this is the new student which was found. So now if I just write a query to fetch all these students, right? So if I write a query to fetch all these students, it will be we have students query, right? So we want to have this, right? So with all these values, right? So you can see that new student Ron was actually added to the students array very successfully. So this is how we basically write a mutation which can mutate data. Mutation could be an update as well as an like as well as an other stuff, like you could have like add student, change roll number, anything like that, and you can basically will be able to do. Okay, that's cool. So you got like a query and a mutation type, right? But what about if you want to have a bigger application and you want multiple resolvers and multiple type definitions, right? So we'll be learning how to do that. So if I just have to tell you in a nutshell, how do you do that? So this type defs and this resolvers could be an array, right? So you could have an array of type defs and resolvers, and you can pass it to this function, and this will basically work. So how I would like to do it is, I will create a new folder called. So I'll be creating a new folder, and I'll call it maybe schema or like maybe type defs. Let's call it type defs, and we'll have a new folder called it resolvers. So you have resolvers and you have your type definitions. In the type definition, we'll be creating a new file called index.mjs. Similarly, in the resolvers, we'll be creating a new file called index.mjs. And now in the type defs mjs, we'll have a new file again over here, and we'll call it student student.mjs. This will be the student type definition, and we could have like a constant over here, and we can call it like student GQL, which is student graph query language, and we could like write like this, which is GQL, and then basically do this, and yeah, and we can just copy our GQL from here, the student, so we do not have to mess this whole area around. This up. And I would like to mention one more thing. You might not get this syntax highlighting. I'm getting this because I have an extension pack of GraphQL installed. And I would recommend you to also install that. If you want to see that, I would like to show you that. So I have a lot of extensions. Yeah, all these GraphQL extensions I have installed just to make working with GraphQL much more easier. So yeah, so we have cut that there, and we have student, and we'll just paste this over here, this type definition, and we'll export this. So we'll say export default these type defs. Oh, this is student GQL. So let's export this student GQL, and what you have to do is you have to go to your index file, import, and write export default and array, and just write student GQL, which will automatically be imported most probably, and there you have your student GQL. And then let's talk about the resolvers. So we'll also have a student resolver. And then what you have to do is you have to take your resolver from here, which is over here, copy this whole thing up. Right. So you can remove this one as well from here on. So in the student resolver, we'll paste our resolver over here, and we can write this to be student resolver, and we can export this by default student resolver, right? By the way, you can do like this export default over here as well, but I would recommend you go like this. The reason is once you like want to reference this in the import file, it will be very easy for you. So you can select export default student resolver. This section, this import statement, you would not have to write. Do that. So once you have your resolver and your type definitions in separate folders, the next thing what you have to do is the obvious step is basically to import them. So let's import resolvers from /resolver / index.js, right? And then next thing what you need is you need your type defs from /type defs / mjs. Once you have both of them, let's call it like schema. Is actually the schema, right? So next thing what you have to do is you'll have to pass this away. So you'll have to pass type defs. I think type defs was okay also. It's type defs and all the resolvers over here. So you have your resolvers and type def passed into this function, which will start the things up. And one more thing I would like to do is I would just write a script over here so that I do not have to do it again and again. So I can say start and write nodemon index.mjs. And but before doing anything there, I will actually have to install nodemon. So I'll say, if you don't know what nodemon is basically a utility, a very helpful tool by which it will automatically restart your server if there is a change in your file. npm run start, which will basically start a nodemon server. Server started pretty successfully, and this is basically the same server running, but with resolvers and type definition in separate folders, and they are pretty separate, and we do not need this as well. Now, basically we need them, but we'll be going serious this time. So the next thing what we have to do is we'll have to set up our database, right? Setting up our database is next important thing to do. So how to set up a database? That's the next question. So we'll be using something called Prisma for that. So so that you guys could see. So if you want to use any other ORM, it's completely up to you. Just go for it. Use anything else. But I'll be using Prisma. I'll say npx Prisma. Yeah. I will initiate Prisma. Let's do. I want to use SQLite for this purpose, but yeah, I'm gonna use SQLite. So Prisma SQLite. Okay, so for Prisma SQLite, what you have to do is you have to provide in your Prisma file, you have your provider, right? You have your this. It's a provider SQLite, and then you can give a URL to the database. I will be giving like I'll be giving /database.db, the database which I want to use, and that's pretty much it. Okay. Oh man, this okay. So we'll what we'll do is we'll just select any one of these folders, and we'll say copy copy path, right? And we'll paste it over here. I don't know, file dot slash. Okay. Does this work? Yeah, it really works. Okay. Oh, Prisma, but I'm not going to do this. I want to do this. Learn GraphQL, and this will go to database.db, right? That's awesome, right? So can I do this? Does this even work? I'm not pretty sure that this folder will like load it properly. File hyphen slash. Okay. I want to go to users. I want to go to me. I want to go to where is my project related. Next thing what I want to do is I want to go to learn GraphQL, and that's the location which we need. So what we can do is we can copy this up, then paste it up, and then we can say GraphQL, sorry, data. So that's the database location, right? So yeah, that's my way of actually getting the correct location. I just go to the browser and I just navigate to that place. Okay, so we have the URL. Next thing is let's write a model. Let's write a Prisma model for our data. So what we can do is we can just write a model, and this will be student because we want student data, and every student will have an ID which will be of type int, and which will be the ID. The default value will be basically auto increment, right? Then it will be a name, which will be a string, and yeah, and then maybe an email ID, which will be a string, and this will be optional. Password, which will be also a string, which will be an optional. Do we need anything else? Not pretty sure. Yeah, so that's pretty much it. We have the student thing, and let's basically make our migrations go. So yeah, npx Prisma migrate that hyphen name in it. If you don't know what that is, it's completely fine. This is all related to Prisma, and you can watch my Prisma tutorial. So basically, you can watch my Prisma tutorial that will cover how these things happen. This will basically create a Prisma folder over here and a data.db over here where all our data will be basically living. Awesome. And one thing what more we'll do basically we'll run one more command called npx Prisma Studio. This will basically run Prisma Studio, and this will enable us to basically see our data very, very easily. So we can just hop in there, go to students, and you can see there's no students at this point right now. But yeah, that's how we do it. The next thing what we have to do is we'll have to actually create, so let's hop into the in the type definition of students, and let's change stuff because that's not the type definition which we have specified in the schema, Prisma schema. Oh, how can I do? Oh man, okay. And I want that close now. Okay. And I just take this. Can I take this, drag into this place? Yeah. Okay, that's fine. So it's just students, and that's how we want our schema to be. So every student will have an ID, which will be of type and integer. Then we'll have a name, which will be of type string. Then we'll have email ID, which will again be of type string. Then a password, which will again be of type string. And I think that makes sense. And if you see these two are optional, so we'll write. I don't know why should the password be optional, but it is. So that'd be okay. So I think rest everything is fine. Everything will work fine. So yeah, we have the student like that with those. So the next thing what we have to do is modify our resolvers because they are not at all connected with the database. So let's do that stuff here. So let's write const client is equal to new Prisma client. That's the client which we need. That's the client which we'll be using for communicating with our database. So you have your client. And next, what you have to do is instead of returning this temp, because we don't have temp, we need the data. So we need students, maybe students, which will be client dot student dot find many. So it will fetch all the students, and then we'll be returning the students. Right? This will enable us to basically fetch everything from the database and return. Next, we are creating a new student. So what you can do is next is basically remove this. Oh, we'll have to change more things in the type defs. So for creating students, you need a lot more things. Okay. So you need basically ID. ID will be auto generated. So name, email ID, and password. So let's change it to name, which will be a string now. Email ID and a password, which will be type string. Yeah, all of them will be a string. So yeah, so we have our mutation like reconstructed. So the next thing what we'll do is we'll say let inserted or let new student, so new stu is equals to client dot student dot create, and we'll pass something called data, and the data will have a name which will be basically args dot name. Next thing what we want is we want an email ID, right? That again will be args dot email, and then the next thing what we want is a password, right? That again will be args dot password. There you have basically the ID will be auto generated. All these information we are passing over here, we are taking a new student, returning it, and we have it. But the thing is, this is an async function, so we'll have to write await over here, and we'll have to write async over here. Similar thing over here, we'll have to write await over here, and an async over here. So you have add student and the student. Okay, we have whatever we had before, but now with our database hooked up, right? So yeah, let's check it out. Let's see how does it work. So as because we have a problem with our schema. Oh, sorry, there's no question mark in this, exclamation mark. I think I've informed you, right? We have a server started successfully. Now it's happy and good, and we can go to this place. Okay, so let's refresh things up a little bit so that everything is happy. Now you cannot have a role and something like that. So yeah, let's remove that thing up. Let's actually try to fetch the students first, right? So I query get students, right? There you go. I need an email ID, I don't want password, name, maybe name. Okay. And once you run this, you get empty because there is no data in the database, if you know, right? So let's get some data from the add student thing. So this as well, and we'll write mutation, and write like add student, right? And then what we can have is we can have like add student, right? Inside that we want message, and we want student. Inside that we have email ID, email name, something like that. And we could like we need name, email ID, and password. So the name, email ID, and password, right? We have all these three things, and let's provide this information here. So we can have like first student will be Jay, email ID will be happy@share.com, and the password will be what? Some pass. And name, email ID, and password. Do we need anything else? I don't think so. Let's see that. The new student has been added phrase successfully. You can see new students added successfully. And now if you go and run this query, you will get the first student phrase successfully. So we have our first student added. Similarly, you can add many other students. So I can say Rohit, which will be maybe Rohit, maybe some different password. Send it. We have the Rohit added and executed. We have 2 different students in our database. That's really cool, right? Okay, so we have these students there, and I think they're happy. Okay, so let's make things a little bit complex now, right? Okay, so the next thing what we'll be doing is we'll see like what is like, so let's say every student have some, let's think, I'm thinking of a data hierarchy which I can explain you. So every student could have like uh, so we could have a teacher, right, under which there could be certain students, right? So every student could have one teacher as a relation, and it could be null if that student does not have a teacher. So let's define that in our Prisma schema right away. So let's create a teacher model. So teacher model, right? The teacher will have an ID, which will be again an int ID and default and auto increment, right? And then the teacher would have a name, which will be again string, um, and the teacher will have an email ID as well. Oh wait, yeah, teacher could have an email ID. Teacher would also have a password, and get lost warning. Okay, so this is a student, but every student will have teacher, right? So we can write like a teacher, which will be teacher, and this will be basically a relation. But before defining relation, we'll be connecting this with teacher ID, right? Which is basically an int, and it's optional. You basically do not need to take care of this, right? So we'll have fields, which current fields. We want teacher ID to be connected with ID, right? Second one. So now this teacher is also like this this is also like an optional relation. So there could be a relation, there couldn't be a relation, and every teacher will have certain students along with them. That's pretty much obvious. So we have a very small relation going on over there. So we every teacher will have some students. Every student will have one teacher. So yeah, means if that makes sense. So yeah, after that, what you need to do is we have to create resolvers, schemas for this teacher as well. So let's start with the schema. I think that's where you always start. Student, sorry, teacher, but MJS, right? So once you have the teacher, we can say const teacher GQL is equals to this, right? And then you can say type teacher. Every teacher will wait. What happened? Oh, we actually need GQL. There you go. So every teacher will have a few properties. Every teacher, if you see, if you look at the schema, every teacher have these properties, which is name, email ID, password, and student, and ID as well. So ID, which will be of type int in our case, name, which will be of type string, and email ID, which will be again of type string, a password, which will be of type string, and it will be several students. Students will be of type student, right? So if you're thinking like where this student type is coming from, it's coming from here. We have defined student, right? So that's the student we are talking about over here. So we have this type student, and we have this student. You got the point, right? And let's write all the queries which we could have in our GraphQL database. So we could have a mutation over here, and that could be like teachers. So we could like demand for all the teachers which is there in our basically school maybe. So teachers, right? And this basically mutation would result in a list of teachers. So that's the teacher. Oh, this is not a mutation. There's a query, man. A query, and we need to create a mutation over here, right? So we could have a mutation. We could have add teacher, right? Add teacher mutation should need
a name, which will be again of type string, and email ID, which will be again of type string, and a password of type string, right? So yeah, so we have all the this thing defined, right? We have add teacher, and wait, we do not need this curly bracket. We need a result type, right? So let's create a type for the result. Let's say type add teacher result, or let's call it result type, because a lot of them will have basically the same structure. A message, which will be of type string, and teachers or teacher, which will be of type teacher. So there you go. You have your start writing then. So yeah, so you can just you know, this over here, and you're good to go. So you have your string teacher, and this add teacher mutation. This is, we'll export this. So right, export default teacher JQL. Yeah, we have it exported, and next, we'll have to add it in the. So we'll have to add it there. Now, the next thing what we have to do is we have to add resolvers for all the teachers, all the schema which we have written. So we'll create teacher .mjs, right? We could have like teacher resolver, and let's start with all the query types first. So query, the first query which we want to deal with is teachers query, and teachers query will give you root, args, maybe context, but we do not need them, so it's fine. Root args is fine. We do not need the context. We'll be talking about context and n+1 problem and a lot of those stuff. Now why? But first it's okay. We have a root and we have an args, right? So what do we want? We want to basically return. So let's actually create a client. Const client is equals to new Prisma client. By the way, this is not good. I'm creating a new instance of Prisma again, which shouldn't be the case, right? So I should always have a singleton instance of Prisma client. But for now, let's go with it. We'll fix this in a while. So we have the teachers, right? So we can say we should have this function as an async, because we'll have a lot of asynchronous calls over here. So we'll say let teachers is equals to find. Oh, I haven't run the migrations, man. Let's get our migrations. npx prisma great hyphen name. Is it like teacher? Teacher. So we have teacher migration, and I think our database is in sync with this migration, which is teacher. So the next thing what we have to do is we have to actually write let teachers is equals to client dot teacher dot not get, it's find many, I think so. Right. And just write a wait over here so that return the teachers. Okay, so you have to run this thing. You have your teachers. Next, this is the teachers query, and okay, we have certain mutations as well, if you remember. So let's write for the mutations. Mutation, and we have add teacher mutation, right? So which is again going to be an async call, root args, and then basically. If you do not need any of these, we can be small and we can call it this as well. It's also good. So yeah, so for the add teacher migrations, we need few things from the args, right? So we'll call it let added teacher is equals to await client dot teacher dot create one, create, and then this you can give data to this, I think, data to this, which is basically data which you want to add. So we will give name, which is args.name. No, I was thinking actually, we can have like this. Name, email, and password. Sorry out there, and then this will be much more easier. So we can say name, email, and password. Save it. There's the added teacher. I think these are the things which will require. I'm not pretty sure of it. So let's go with this. So we have name, email, and password. And do we have anything else? No, we don't have anything. And we have to return teacher, message, and teacher as. So we can go to return and again message first, new teacher created successfully. So you basically create a new teacher, and then you actually have to pass the teachers which was added. So added teacher. There you go. So you have an mutation, which basically added a new teacher and returned you that. So that's pretty cool. So if you don't have this, so yeah, let's return this and let's try this out. Should work, I believe. For default, teacher resolved. That's pretty much cool. So we'll go to this, and we'll call it teacher resolved. But we have something broken, I'll tell you. If you look at the teacher student, we'll do that later on. So we basically want a teacher parameter over here, because every student will have one teacher. So we'll think about that as well. So yeah, I think if our server is running up and fine, we don't have errors. If we don't, we can just try this out. So we name this something. I'm not very sure. Okay, let's have a new thing and let's call it a teachers. This is the teachers. So out of fetch. Okay. Students. And if I don't want students, then so we have no teachers currently, and the students which I removed will be dealing with that situation in a while. Just give me a second, okay? We'll be dealing with that situation. So this is students, right? That's wait. Is it visible? Yeah, I think so. Yeah. Okay. So let's make it a little bigger. Okay. So you can definitely see that these are the teachers which are being returned, right? Which is empty because we haven't created one. So let's actually write a query. Let's write a mutation called create teacher mutation, and let's call it create teacher. Let's teachers. Should I refresh it? Why isn't there auto completion for create teachers? I don't know. Something wrong. Okay. So wait. There's something wrong with that. I think so. Okay, we have teacher QL. We have teachers query. We have a mutation called add teacher. Oh, let it be. We'll have add teacher mutation. Now this will take name, email ID, and password. So name, email ID, password. And then what do we want from this? So we want we want message, and we want the teacher as well. So maybe email ID of the teacher. That's all. So if we just send this request, this should create a new. So this gives me an error. Add teacher invalid Prisma create invocation failed. Parse type matching unable to match input type to any allowed input type. Oh, the problem is, if you see, we have passed null, null, null as a type, right? So, we need to get that right. So let's actually pass some correct name. So let's add a new teacher called Rohit. Right? Let's add an email ID called rohit@gmail.com and the password as well. So we'll be passing a password over here. We'll call it Rohit, things like that. And let's create the teacher. So you have the new teacher created with the email ID, right? So if I just send this request from here, you'll see that the new teacher has been created pretty successfully. That's damn good, right? So we have the teachers things sorted out, but we still don't have one thing sorted out: how to get all the students which is under this teacher, right? And how to basically assign a student to a teacher, right? It's also a deal which we have to basically go with. Okay, let's deal with the first situation, which is assigning a student to a teacher. So that's actually a mutation which we have to write in the student's schema. So, here's the mutation. So let's call it assign teacher. Right? So we need a teacher ID, which will be of type int. Right? And next is we want a student ID. So to which student ID you want to assign that teacher to, right? And then again, this will be typed. Uh, you can do this. That's one option, or you could like directly do this. I think so. We can do this. Right? You can say, this will be message, which will be a type string. Right? And then you could have like an maybe student, which will be a type student. So okay, that's good. So you have your assigned teacher mutation. So now what we have to do is you have to make a resolver for this particular mutation. How you do it is you just go to the student. You have your add student over here, and then you'll write. You'll have your root, your args, everything. We only carry about we'll only care about args because that's what all what we pursue args. Now there's two things in the args which we are interested in. First is teacher ID and student ID, right? Where is the student resolver? So we want teacher ID one and teacher ID and the student. Yeah, the teacher ID and student ID. What we have to do is wherever the student ID is there, update that with that teacher ID, right? So we have the client over here. I think so. Right? So that student dot update right click where uh, where the ID is student ID. I think then the data is what do you want to update? So I want to update the teacher ID. The teacher ID would be the teacher ID. There you go. I think this is how you write update query. I'm not really sure about it, but yeah. This new student. Right? It should be new, not it should be updated. Let's write await over here and let's return this. I'm doing some kind of mistake. I don't know why. Okay. This should there. Right, right. Sync over here. do this. And then yeah, this fixes this bracket issue. Now the next thing what you do is return this as per like assigned teacher to student. So we have assigned this teacher to the student, and then basically you can pass this updated student to, you know, but you know this needs. Yeah, there you go. But I'll have to make sure that this is as per like what we have written in the message string. Yeah, that's correct. Okay. There you go. We can now assign a teacher to a student, right? Good. Okay, let's try to do it. Right. So first of all, let's try to fetch all the teachers. So there you go. Failed to fetch. Okay. We had some error. Okay, this is the error. It's, you know, we have some error in the GQL syntax. I think right, that's my assumption. Right? Let's see the console log. So it says GQL error, found this, found something else, destruction. Okay, it's fine. So the next thing what we'll do is we'll basically go to we'll go to the type depth. Okay, wait, is it my mistake or the this is something else? Okay. The student thing, let's keep it separate. Keep it type sign. Yeah. Here. Copy this, paste this over here. Yeah, there you go. Is it correct? My server? Oh no. It's angry at me. Oh, what did I do wrong? Come on, where's the mistake? Syntax this found fixed. Syntax error. Where's this error? I don't know. Where is this error? Okay. Okay. Is it in the teacher? I think we did not do any modification in the teacher, so that shouldn't be the issue. In the student. Oh, wait. This should be again an int, right? That was the mistake. So yeah, the server starts successfully. Let's go and let's hope we're able to fetch all the information again correctly. So we have all the students, right? So we want student, and let's see, we have the students. We wanna assign Rohit as a teacher to student one. We'll write one more query and we'll say this is actually again a mutation, assign mutation, and we wanna say assign teacher. Your message as well as student thing, that's what we want. And you know what we'll do is we'll pass teacher ID and student ID. Teacher ID 1 to student ID 1. So there's assigned and the student name is J. Yeah, that's what we want. So yeah, that's very much cool. We have assigned a student to a teacher. Let's say we want to give this information to the client as well. You know, how will you do that? That's also not very difficult. Go to the type definition, right? In the this just write a teacher and just write a teacher over here, right? And then just give an exclamation mark, because you know there could be a teacher, there couldn't be a teacher. It's completely. So what you do is inside the student schema, you'll have to handle this teacher thing, right? So yes, let's do it. So yeah, so let's go to the handler, right? And here there's like, you know, if you can create the handler for this mutation query on the top level, you can also create a handler for the student thing, right? If the student have an if the student have a teacher as a parameter inside that. So you have a root, you have the args. Those are pretty much efficient. So if you want to know what is the root is the student, right? So it's like the student for which you want the teacher, right? The student will have a teacher ID. So it's pretty simple. We'll say teacher is equals to find dot find dot teacher dot find first, and we'll have where uh, the ID is root dot ID, root dot teacher ID, root dot teacher ID. So you have your root dot teacher ID. That's basically your teacher, right? So we'll have to return this, right? So return this teacher, but now as this is an async operation, we'll have to write async await. So yeah, there you go. You have student, and inside that we have. But wait, I'm just. So we have the student resolver student. So we have this teacher, right? Yeah. So once you do this, I think you will be able to very successfully do very amazing stuff. So you can see, we have ID. You can say teacher as well, and I want the name of the teacher who is assigned to this like students. You can see, it says, okay. So the question is, what if a student does not have a teacher, right? That could be a case, right? So that's the case. So if args or teacher ID is something which is not defined, there's no args or teacher ID, return null. There's no data about that. So if we now display it, you can see, cannot return null for non-nullable field teacher. Okay, teacher is not nullable field, which is not correct, right? So that should be nullable. Uh, So let's return an empty data for now. We'll see how to create a nullable field afterwards, but for now, you know, instead of this, let's return this. Yeah, it works. So you can see, this is null basically, but we do not want the teacher to be there. How to create a nullable field in graph? Create a nullable field. Yeah. See, this is okay. That's important. I was sorry. It's my mistake. I explained you the opposite, right? So basically, this is required. These are the things required, and this means this is nullable. So we'll just remove these. These are not at all required. Similar thing, As now we have done that, I think we should be able to return null. Resolver. We could say null to this. Okay. We have null. So now if we just run it, I think it will be something like this. So teacher is null because there's no teacher for this particular student, these two students. Yes, teacher for the student. Okay. There's no teacher ID. Is it due to like this? Okay. That's true. I'll tell you the reason why is it happening. Okay, the student is there, and this is very weird. Should we make the teacher ID what is the issue? Okay, let's actually try to log the. Oh wait, why am I saying? Am I saying R? So it should be root, right? So root has the teacher ID as a parameter. So I'm going crazy, I think. Okay. So now you can see the teacher name is Rohit, but the teacher is null over here because there's no teacher. Yeah, works perfectly fine. So that's how you chain up the uh, the request, right? So inside students we have teachers. Inside teacher we could have students as well. So let's try to handle that case as well. So inside teacher we could have students as well. So we can have like students. Yeah, we already have it. So let's try to handle this case as well, right? How do we do that? So basically go to the resolvers, go to teacher, and just write a resolver for that case, right? So we have mutation, teacher, right? So for the teacher, we want like, what would be the resolver for our students? Yeah, we have a root, we have an arg. So from the root, what we want is we want the teacher ID, right? We want the teacher's ID. Okay. Okay. So root dot okay, let students be equals to client dot students dot find many where where the ID is basically the student ID, where the teacher ID is basically root.id. So you have all the students. Again, not this async, not this await, and you have your students, and you can just return this. I think there you go. So you have, inside teacher, if you ask for students, you'll get the students who belong to that particular teacher. So yeah, so if I just go to teachers now, and if I just say students, and I want the name of all the students, so I can just say this, and you can see an array. This particular teacher whose name, his ID is 1, name is Roy, email ID is this, password is this, and serving password like this does not make sense. Of course, we would never do that. But yeah, here's an example. I think that's how you do it. So there's a problem with it if you see this approach. There's like, if you have n depth, right? N depth, and not even n depth. Imagine, having 10 teachers. For all those 10 teachers, we have one additional query, right? So we have n plus one query, right? So for every n, we have plus one query. So that's bad, right? So every, like, let's say, there's a teacher, then again this query would run. There's a teacher, then again this query would run. This is very bad. And it's called n plus one problem. Now this is not in the scope of this, but I think you understood the problem, right? But I would definitely guide you through like where should you go, like to find plus one problems, n plus one problem in GraphQL, right? So there's a Medium article about this, and basically there are two approaches to this, right? One is called using data loaders. So let's not discuss, let's not have a vague discussion. We'll have an in-depth discussion. I'll be creating a problem of this. I'll be creating a video on this, like basically what is n plus one problem and how to solve it is, and discussing both of those ways. Okay. So yeah, I think we pretty much made a GraphQL, a GraphQL server. Right? So let's actually see, what can we do? What is its capabilities, right? So let's create a new. Let's try to query data. Right? So we'll click. I want to query data and query data. Anyway. We don't care. We want students, and we want every student's email ID, name, right? And we want teachers as well, and we want email ID and all the students which are there inside those teachers, and I want to name that. So I define the structure. If I just call send, I have all the desired data, which basically in this particular structure, and we have it. We have name. We have everything. So that's pretty much it in this video. I also you learn about GraphQL, and this was something which benefited you. Thank you for watching, and have a very, very great day ahead. Thank you. Have a good day.